Talking about problem statement, this dataset consists of TV show and movies available on Netflix as of 2019. The dataset is collected from Flexible, which is a third-party Netflix search engine. In 2018, they released an interesting report which showed that the number of TV shows on Netflix has nearly tripled since 2010. The streaming service number of movies has decreased by more than 2000 titles since 2010, where it its number of TV show has nearly tripled. It will be interesting to explore what all other insight can be obtained from the same dataset. Integrating this dataset with other external datasets such as IMDb rating, Rotten Tomatoes can also provide many interesting findings. Talking about project summary, while we are going to perform following operations such as import library, loading the dataset, shape of data, dataset information, handling the duplicate value, handling the missing value, understand the column, variable description, data wrangling, data visualization, storytelling, text pre-processing, latent direct allocation, sediment analysis, change phase, and last but not least, conclusion. Business problem, exploratory data analysis, understand what type of content is available in different countries. Is Netflix has increasing focusing on the TV rather than movies in recent years, clustering similar content by matching text-based features. Here is a data description. Let's begin. Firstly, we're going to mount our drive as well as import library. Here is our first look of our data set, df.had, and here is the last look of our data set, that is df.tel. So, we having that 7,787 rows and 12 columns in our data set. Data pre-processing deals with null value and missing value as well as deal with the duplicate data. Here is our df.info, dtype int1 and object 11. Here we use memory 730.2 plus KB. So we know that there is no duplicate value in our data set. There is 3,631 non-values. We found that there is no duplicate value in our data set. There are 3,631 non-values in our data set. 2,389 non-values in the director column, 718 non-value in the cast column, 507 non-values in the country column, 10 in data added, and 7 in rating. Every row of information we have related to a specific movie. Therefore, we are unable to use any method to impute any non-values. Additionally, due to small in size of the data, we will handling non-value after EDA. So, we're going to understand what is the variable. Here we have data column, dataset column, df column, and we having a df.describe. So, why we using EDA? And EDA is the thought of examination mean to be uncover the underlying structure of data set and is important for a company because it exposes trends, patterns, and relationships that are readily apparent. So, data visualization and storytelling experiment with charts. Understand the relation between variables. Here is the chart 1. We show the count plot of type, like how much we having TV as well as movies. So Netflix has 5,377 movies and 2,410 TV shows. There are more number movies on Netflix than TV show. rating. Now we found that the majority of movies and TV shows have a rating of TVMA, which stand for mutual audience, followed by TV14, which understand younger audience. When compared to TV shows, movies receive the highest rating, which is pretty obvious given that a number of movies are higher compared to TV shows, as we saw earlier in the data type column. Release year. So we found that Netflix start releasing movies, TV show in the recent year compared to old ones. The most movies and TV show are available on Netflix between 2015 and 2020. The highest rating are in 2018, which we clearly see in this graph. Talking about directors, so we get insight from this. There are 3 shows directed by all-star Portugal are the highest on the data list. Both Sansuiter and Roll Compose have directed 18 films more than anyone else in the dataset. Cast. The majority of the movies are played by Anupam Kher, Shah Rukh Khan, Om Puri. In TV show, Tarakiryu, Shaukaria, Yuki Kaji, and Daisuke Ono played the most number of roles. Talking about country, the US-based movie and TV show were produced most, followed by Indian and the UK. In India and US, a greater number of movies are present compared to TV show. In UK, Japan and South Korea, there are a greater number of TV show more than movies. So listed in international movies, dramas and comedies make up the majority of the genes. TV show, classics and cults, TV thrill, stand-up comedies, and talk show according for the last genes. So here is a title. Word like love, Christmas, man, world, life, girl, and story are the frequently used in movie title column. The most frequently word in the description column are family, find, love, new world, and friend. Propologies from different countries. In this graph, we can see that the Argentina most movie like, then drama, then TV show, and so on. As Australia, they like international movie, family movies, drama, and so on. Handling outliers. Except for the release year, almost all of the data are present in a text format. The textual format contains the data we need to build cluster building model. Therefore, there is no need to handle outliers. Handling missing value. The empty string can be used to replace the missing value in the director, cast, and country attributes. There is a small percentage of none values in the rating and data edit column. Eliminating these none values, we will have the title little effect on the model construction. As a result, the none value in the rating and data edit column is simply removed. Data, textual data pre-processing. It is mandatory for a textual data set, that is NLP, sediment analysis, text clustering. The textual data pre-processing is the process of preparing data, text data for analysis or modeling. It including a series of steps that are applied to raw text data in order to clean, organize the standardize it so that it can be easily analyzed or used as an input for NLP or a machine learning model. So, why we choose such a models? What is the approach behind that? Choosing the attribute that you want to cluster, text pre-processing, change all the textual data to lowercase and eliminate all punctuation marks and stop word, removing commonly occur words such as the, and, a, etc. Don't much meaning. Steaming or a limitization, normalization the word by reducing them to their best form. Tokenization, breaking the text into a smaller unit such as sentence or word. Dimensional reduction, make a use of various algorithms to cluster the movie and various techniques to determine the optimal number of cluster. Build the optimal number of cluster and use word cloud to display the content of the each cluster. So move on with these. Removing non-ASCII character, expand contraction, lowering case, removing punctuation, removing URL, removing words and digit, contain digit, removing stop word and removing white space, tokenization, text normalization. We have to use lemmatization as the text normalization technique because it reduces word to their base form, which can help with the text analysis and understanding. It also helps to provide duplication of the word with different inflations and make it easier to perform analysis on the text. Additionally, lemmatization is the more accurate than steaming as it uses directory-based approach to identify the correct base form of a word. Text vectorization. Here we are going to split text X. We having a shape 7,787 and 20,000. We have to use because it is a statistical measure used to evaluate the importance of a word in a document corpus or a corpus. The TF-IDF score for a word is a proportional to frequency of the word in the document, but inversely proportional to the frequency of the word in the corpus. It is only the capture the frequency of the word in each document, but also take into the account the rarity of the word across the corpus. Dimensionality reduction. Yes, dimensionality reduction is needed because it reduces computational complexity and improve the performance of machine learning algorithm. Also, as the number of featuring or a dimension increase the amount of data required to adequately represent the data also increase. This can lead to overfitting, a phenomenon known as a curse of dimensionality. Here is a PCA, cumulative explain variance versus number of component. We discovered that approximately 7,500 components account for the 100% of variance. 3,000 components alone account for more than 80% of variance. Therefore, we can take the top 3,000 components to reduce dimensionality and specify the model while still being able to capture more than 80% of variance. So, move on with ML model implementation. Here is a ML model 1, K-mean clustering. K-mean clustering is a popular unsupervised machine learning technique used to group similar data points together. The goal of K-mean clustering is to partitions a data set into a K cluster where each cluster contains similar data points and is represented by its centroid. The K-mean cluster algorithm worked by the first randomly selected K centroid, one for the cluster, one for each cluster. Then it assigned each data to the cluster which centroid is closest to it. This process is repeated until the assignment of the data points to the cluster no longer change or until a maximum number of iterations is reached. So here is Almabetter to find optimal value of k. The sum of square distance between each point and the centroid in a cluster decrease with the increase of number in cluster. Here is a She-Hothe score method to find the optimal value of k. Now move on. Number of TV show and movies in each cluster K-mean clustering. Here is this. Successfully build 4 clusters using K-mean clustering algorithm. Building word cloud for the different cluster in K-mean clustering. Here we see that description column for different cluster, cluster 0, cast, we having 1, 2, 3. Here we having country. Again we having a 1, 2, 3 cluster. Here we having a title. Again we having 1, 2, 3 cluster. Now talking about ML model number 2, hierarchical clustering. Hierarchical clustering is a method of clustering data point into a tree-like structure. It is an alternative method to K-mean clustering and it is used to group similar data points together in a hierarchical fashion. So, dendrogram distance, you see in this. At a distance of 4 units, 7 clusters can be built using this algorithm clustering algorithm. Building 7 clusters using this algorithm clustering algorithm. Sample. Here we having type, director, title, cast, country, rating, listing, description, so on. Number of movies in movies and TV show in each cluster. So here is the graph. Hierarchical clustering. Successfully build 1, 2, 3, 4, 5, 6, 7. Okay. Successfully built 7 clusters using algorithm hierarchical clustering algorithm. Building word clouds for the different cluster in hierarchical. So here having a title. First we start with the title. In this we having a title column for the different cluster. Here we see this 1, 2, 0, 1, 2, 3, 4, 5, 6. Now we having range description. We also having in this 1, 2, 3, 4, 5, 6, so on. Here we having a cast, same as it is. We also having cluster 1, cluster 2, cluster 3, cluster 4, cluster 5, cluster 6, so on. Move on with the country column. So here we also having a cluster 0, 1, 2, 3, 4, 5, so 6, 7. So total we having a 7 cluster, 0 to 6. Now in genre, also we having 7 cluster, 0, 1, 2, 3, 4, 5, 6. Now talking about conclusion. In this project, we tackle a textual text clustering problem in which we had to categorize the group Netflix show into a specific cluster in such a way that show in the same cluster are similar to one another and show in different cluster are not. The problem of dimensionality was deal with thought the use of principal component analysis because 3000 components were able to account for more than 80% of the variance. The total number of components was limited to 3000. Utilizing the K-mean clustering algorithm, we first constructed cluster and the optimal number of cluster was determined to be 4. The elbow method and Shihot score analysis were used to get this. The algorithm clustering, which is known as a hierarchical clustering, was the was then used to create cluster, and the optimal number of cluster was determined to be 7, 0 to 6. This was obtained after visualizing the dendrogram. So